PLPR is basic visual inspection done on a train which consists of 7 cameras underneath the belly of the train which cover from sleeper end to sleeper end.
3 looking down at the track, 2 looking diagonally at the web of the rail, on each rail, and 4 laser profile cameras.
It can identify missing clips, high ballast, incorrectly fitted rail clamps. It also identifies rail joints. It also identifies dip angles and any track geometry fault.
We've also got 2 thermal imaging cameras fitted to the train. They'll be used on third rail areas to look for where we've got loose connections causing heating up, which could eventually lead to arc damage.
Omnicom line scan, which gives you the 7 cameras for the PLPR, is capable of recording from the moment the train starts moving until it reaches 125 mile an hour. The profile lasers, which laser the ballast over the clips or the shoulders or in the 6 foot, that starts recording at 5 miles an hour and goes through to 125 miles an hour.
The line scan images are recorded at 0.8 millimeters and then sewn together to create a very, very high resolution video type image. The profile cameras take an image every 20 millimeters and the thermal imaging camera works in a similar way to a video camera.
We have got an RTPS system, which is the equivalent to like a road sat-nav, which will tell us the mileage, and basically it keeps a log of wherever the train has been during the day, what road the train has been on.
A key output from the system will be improved asset information in that it's consistent. We reduce the number of work orders that are duplicated and provide longer term degradation information so that we can understand how quickly assets degrade.
Majority of the defects that we find tend to be ballast, ballast covering clips. Well, it will come across with just one single clip that's been out, and when you consider that there's miles and miles of data that we've been through and inspected, it's very, very good.
We've had very positive feedback from the section managers on the quality and consistency of the output and the fact that it matches reality on the ground when they've gone out and done validation checks of their own of our output, and they've been very complimentary about the quality of it.
The main advantage is the fact that we're having, rather than walking 5 miles and having to find the faults, we are travelling 100 miles, for example, and we're having the faults shown to us by the computer. So effectively we can inspect more in a possibly less amount of time than what it would take to walk.
PLPR is quite often described by their professional head of track as the most important project Network Rail is currently delivering. It is fundamental to helping us be more efficient, helping us be safer, improving the way that we manage our assets, improving our understanding of assets and degradation characteristics of the track, so that we can improve our long-term strategic planning as well as the short-term method for delivering inspection.